Hello friends, welcome to our channel. Let's have a look at problem 3551, minimum swaps to sort by digit sum. In this video, we are going to explain a solution based on sort and the find method. So the find method is quite similar to the one in the union find. So here, the purpose of this function find is to track circles. So it was retrieve or track circles. Once we know the circles of the indices, more explicitly, if we know the length of the circles, we know the number of swaps we need, right? So then we just total the swaps needed by each circle. Then we get the result. So actually, the problem logic is rather straightforward, but here I want to point one thing, that is the numbers are distinct, right? And this is very important. Another thing is that when we do the sort, so we need to sort according to a hierarchical key. One is digital sum, but the other is the number itself. So if the digital sums are the same, and then we need to sort the array, so smaller number should be in the front, right? So this is the case for this one. For example, 43 and 34. 34 should be in front of 43, right? So here actually we can do the problem according to the hint, right? We can first sort the array and then retrieve the supposed position of each number, right? Then this way we can actually translate this problem into arranging the indices. Then we can do this cycle tracking, right? But I'm not exactly sure of the meaning of hint 2. So with that said, let me do the coding first. So first I'm going to get the length of nums. So this is just for some convenience later. In order to get the digital sum, actually we can do it in a algebraic way, or we can just use some type conversion. So let me define this function as a key later. So digit sum. So given a number, let's say x. So if we want to find the digit sum, we can initialize a result variable, and then while x is greater than 0, we do something, and then finally we return the result. First, if x equals 0, then the digital sum should be 0. So it does not enter this while loop. Therefore, we can directly return the result state. Otherwise, we can do this, r def mode, so x divided by 10. So then we increment this result by r. So notice that this line of code does two things. One is to get a digital in a certain position. Another one is to update this x to the current state. So this x is essentially x divided by 10. So this is the code. This is the one way. Another way is that you can digit sum. I'm going to write an identical one. So you can do something like this. Sum integer y for y in string x. So you can translate x into a string and then do a linear traversal, then add the number. So this will give you a digital sum, right? So this function is going to be used as a sorting key or part of the sorting key. So now let me get a sorted numbers. So we can use sorted method because I don't want to modify the nums in place. So here, this is what we want to sort, and the key will be a lambda function. So you have x, so map to one is digit sum x, one is itself, right? So if there's a tie in digit sum, so we are going to put smaller x in front. So you can print out this sorted nums. So for example, if you sort, so this one has digit sum 0, it should be in the front, and then this in the second place. So if you look at case 2, this has digit sum 4, so you get to put it here. This 5, the 6, and 7 remain their original position. For this one, 16, this is 7, right? This is also 7, this is also 7, but 16 is the smallest one. This is the second smallest one, is the largest one among these 3 integers with digit sum 7, right? So this one has digit sum 9, should be in the last. So here I'm using this digit sum. So this is from arithmetic way. So you can also change this to be the revised form. So because this is using type conversion. So same thing, right? You can see here, right? 16, 34, and 43. So I'm going to recover from this first one. You can use either one, right? So now once we have this one, so we can what we can do, I can actually have a dictionary. So dictionary is yi for y in enumerate sorted nums. So this gives the number and the corresponding indices. So now if we consider the original array, so we can get the original index and then we can call that number to get the current index. So this should be the final position of that number or that index. So what we want to do is that indices is d of y for y in nums, right? So you can also print out this one to have a feeling, right? So for example, original index 0 should be in index 1. The index 1 should be in index 0, right? So this gives us the needed information. So next I want to get the cycles, right? So let me print out this indices. So this one is just to have cycle 0 and 1. So this one you have 0, 0, 1, 1, 2, 2, 3, 3. And for this one, the index should be 0 should be in 3, and 3 should be in 0, and 1 should be in 2, and 2 should be in 1, right? For this one, 0 should be in 2, and 2 should be in 1, and 1 should be in 0. So then in order to get the minimal number of swaps, let's define a function called DFS. So this is actually the find function in a union find. It's essentially the find function in union find, right? But here what we are using this is for checking the cycles. So let me first get this set. Then what I'm going to do is a current set to be the current index. Then we are going to use a while loop while current does not equal to indices current, right? And current not in result. So what I'm going to do is result add, because it's a set, add current, and then set current to be indices current, and then finally we return the result. So now let's look at the problem logic. First, I want to get all the cycles. So I call it information. It's a list of sets. Each set represents a cycle. So we are going to, let's see, I'm going to use a visited to avoid repetition. So for I in range m, right? And then if I not in visited, so we are going to do traversal. So we have a S as DFS I, right? Then we are going to append this information to append this set to the information, and then visited union equals this set. We can print out this information. And also we can print out this indices. You can make a comparison. Indices. For example, case 1, so you have this 2 should be swapped, right? And for case 2, so nothing should be swapped. We have 4 empty sets. For case 3, so index 0 and 3 and 1, 2 should be swapped. For case 4, this is special because we have 3 indices. So actually, this should 0, 1 should have swapped, and 1, 2 should have swapped this 3 position. But the number of swaps is this total number of indices minus 1, because there are 2 edges among 3 indices, right? So with that done, now let's prepare the return. So what we want to return is nothing but sum of length s minus 1 for s in info if the length of this s is greater than 1. In other words, greater than or equal to 2, right? So if the default of sum is 0, right? Let me run it. So you have case 1 is 1, case 2 is 0, case 3 is 2, case 4 is also 2. So now let's submit for the generic case. Yeah, it passes all the cases. So I would say this is one way of doing this problem. So here what we used is a sort to get the final position of each number or each indices. So here the way we can do the coding like this or do the solution like this is largely due to this assumption, distinct positive integers. And then we use some ingredient from the typical UniFind implementation. So we use the find method. So if you're not familiar with UniFind, you can practice using our playlist. The playlist name is UniFind in our channel. So with that said, I guess that's it for the current problem. Thank you for watching.